Let's go over building and training CNNs with TensorFlow. Now, building and training convolutional neural networks CNNs with TensorFlow involves using its high-level APIs Keras, which provides a user-friendly interface for constructing and training deep learning models. Let's delve deeper into the process of building and training CNNs with TensorFlow. First step, import TensorFlow and Keras. Starting by importing TensorFlow and the necessary modules for Keras, we do if you see here in this example, we are first importing TensorFlow SDF. Now from Keras we are importing sequential, and from Keras layers we are importing conv2D, the convolution, max pooling 2D, and flatten and dense. Next step, we define the architecture of your CNNs by stacking convolutional and pooling layers, followed by fully connected layers for classification. So that's why we use the sequential algorithm architecture, and we use the conv2D, max pooling TD, conv2D, max pooling, then flatten and then dense, with the two parameters 128 activations of ReLU and 10 and activation of softmax. This is something that we've done before, but this is more into the details of it. Next, we compile the model. We compile the modeling by specifying the optimizer, the loss function, and the metrics to be used during training. So if you see here, we use the model.compile, optimize using Adam, loss is using sparse categorical cross entropy, and metrics is accuracy. Next, we load the pre-processed data. Load and pre-process your data set. For example, if you're working with image data, you may need to resize the images and normalize pixel values. You do that by xtrain ytrain and then xtest ytest is equal to tf.keras.datasets.mnist load data, where we're taking the data from the mnist. Then we are xtrain equal to xtrain.reshape. You're giving the parameters, or you want to shape it as float divided by 255. Same thing for xtest, with xtest.reshape, give the parameters and as type float 32 about divided by 255. Next step is training the model. Train the model using the fit method, specifying the training data, number of epochs, and batch size. So if you see here in this example, model.fit, we give the xtrain ytrain, then epochs is 10, batch size of 32, validation split is 0.2. Lastly, evaluating the model. Evaluating the model's performance on a separate test data set to assess its accuracy and generalization. So I say test loss test accuracy tuple, which I can get from model.evaluate xtest ytest, and then I can print the test loss and test accuracy. Building and training CNNs with TensorFlow is made straightforward with the Keras API. By following these steps, you can quickly construct, compile, train, and evaluate CNN models for various computer vision tasks. Experiment with different architectures, hyperparameters, and training strategies to optimize the performance of your CNNs for specific applications. Additionally, consider techniques such as data augmentation, regularization, and transfer learning to further improve model performance and robustness.